There are many different types of fermentation. For our demonstrate, we're going to talk about the alcohol fermentation that occurs in the making of ginger ale.
So what do we need to get started? I'm thirsty.
So the first thing we're going to need is an anaerobic environment.
That sounds complicated.
Actually, anaerobic simply means no oxygen.
So if I hold my breath, then I'm in an anaerobic environment?
Well, sort of. You are creating an anaerobic environment, but you need oxygen. So if you keep holding your breath, you will pass it.
Can we get back to making ginger ale?
So our anaerobic environment, or the place that our chemical reaction is actually going to happen, will be this empty 2-liter bottle.
Next, we'll pour in a cup of sugar. And a 1/4 teaspoon of yeast.
Then we're going to add some grated ginger, about 2 tablespoons, and about 1 tablespoon of lemon juice.
Then we are going to add some water, or since we are being scientific, H2O. Until it is about half full. Then we are going to cap it and shake it until it is mixed up.
After you're done mixing it, you will add the rest of the water until it is about 1 inch from the top. It's quite a lot of water.
H2O.
H2O. And then you will cap it and mix it one more time.
So now we're going to store it in a warm place. Room temperature is probably fine for about 2 days. And during that time, the chemical reaction is actually going to happen.
Well, this doesn't sound like science. This sounds like we're just following a recipe to make ginger ale.
True, a chemical reaction is like a recipe in that the elements we need are like the ingredients needed in a recipe.
Ours looks like this. So this is our chemical reaction here. Here we have sucrose, which is a large organic macromolecule where the carbon, hydrogen, and oxygen are bonded together covalently, which means they are sharing electrons. And what's happening is the sucrose is being added to the water, and then during our chemical reaction, we are creating carbon dioxide and ethanol. And what actually happens is the sucrose is breaking apart, those covalent bonds are breaking. So it's a decomposition reaction because it's breaking apart. And then we produce carbon dioxide, which is a gas, making this a decomposition gas-forming reaction.
So you mean all that's happening in a bottle?
Yup, let's break it down some more. You know the yeast we added?
Yeah?
That is a single-cell fungus.
That doesn't sound like something we should drink.
Yeah, well, maybe we need to show you some more. Can I have 3 volunteers? Can I have 3 volunteers? Okay, let's do one right there. And let's do one right there. Yeah. And let's do one right there. Very close. Come on over here. You're ready. And here you go. Oh, where is the back member? Okay. There we go. Good job! Let's have you stand right there. There we go. The back member is coming. There we go.
You look like a nerdy hipster.
Okay, there we go. Very nice. Yeah. Very nice. Stand in a row like this.
Our lovely volunteers are going to function like the yeast in our ginger ale, and they're going to show us how the fermentation process works.
After a while, the yeast get hungry, so they start to eat the sugar.
Get some sugar. Take some sugar. Take some.
Now the sugar we use is called sucrose. Remember? It's the C12H22O11 part of our chemical reaction.
You had one job.
I have 2. I have to eat sugar.
Right. So sucrose is made up of 2 parts, glucose and fructose. And what happens is during our chemical reaction, these 2 sugars go through a chemical process known as glycolysis.
Hold on, science girl. What is this glycolysis?
Glycolysis is the name of a process where sugar is broken down into pyruvate, the stuff that makes ethyl alcohol.
Pyro what?
Pyruvate in humans turns into lactic acid, but in yeast it turns into ethyl alcohol.
What's lactic acid?
Lactic acid is what's produced by the cells in your muscles when you exercise. It's what makes you sore.
So if we were like yeast, when we exercise, instead of getting sore, we get drunk.
Now, as our yeast continue to eat, they are actually gaining energy, or ATP, also known as adenosine triphosphate.
As a product of making all this ATP, or energy, the yeast produce small amounts of ethanol and carbon dioxide, also known as CO2.
Blow your bubbles, yeast.
All right, yeast. Release your CO2 appropriately, please. Blow the bubble. Release your CO2. This is CO2.
In the end, this is what makes our ginger ale carbonated.
And slightly alcoholic. All right, thank you, volunteers. Very nice. Thank you, volunteers. Hey, give me my bubbles back. Hey. And my hat, please. Thank you. Thank you. Thank you.
You're wearing jeans.
So the bubbles that tickle my nose are really just CO2?
That's right. Now, to finish our ginger ale, after 2 days of letting the yeast do what yeast will do, we take the bottle and we put it in the refrigerator to stop the fermentation process.
How does putting the bottle in the fridge stop the chemical reaction?
But when the yeast get cold, they get sleepy, and they don't have the energy to keep eating and digesting the sugars.
Which is a good thing, too, because if too much gas is produced, the bottle will explode.
Holy fermentation! That must be why we're wearing these goggles.
Once the yeast is done, the ginger ale is ready to drink. Let's try some.
TV magic.
Yes, TV magic. We have done ginger ale. Okay.
Fuck up.
As you can see, it's quite carbonated.
It will explode.
It will explode. I'm scared of making this.
Oh, it will explode. See, yeah.
Don't be a parent.
Full stage effects. Special effects.
Think of it as a decoration.
Oh no. Oh no.
Not bubbly.
I made some into a cup. We're good.
Most of it.
All right.
Someone will drink.
Yes.
Yes. They would need a lot more.
Science is delicious.
So, the next time you are in your kitchen, remember, you're not just making something to eat or drink. You are making a culinary reaction. Any questions? Very good. Very good.